All right, guys, so this is going to be our video on the eyeball and vision. It's going to match pretty well with your packet, but I'm not necessarily going to go in the order, so I'm going to start actually by labeling this picture here, and then we'll go back to the part above where it talks about like the posterior cavity and the various layers of the eye, and we'll kind of tackle those, okay? All right, so labeling here, and you guys have boxes down below, but we'll go through this. So the very outer layer, this kind of covering right here, is going to be the cornea. Sorry for the bad handwriting on here, okay? Number two, that opening where the light's gonna come through, that's the pupil, okay? Number three, the surrounding around the outside of that is gonna be the iris. That's the colored part of the eye that opens and closes and make the pupil larger, right? Let's go to the back here. The eye itself has three layers that are kind of stacked. So 4 is the retina. Okay. 5 is underneath that. That's called the choroid coat. Okay. And then 6, the white outer portion of the eye, is the sclera. 7, coming off the back here, is the optic nerve. Okay. And there's some other parts in here that we're going to kind of go through here in a second as well. Okay, so right above that, there's a spot that says the posterior cavity of the eyeball holds the. So that's this whole back section, and this whole back section is filled with this jelly-like stuff called the vitreous humor. And the humor is already on your packet there, but the vitreous humor, okay? And it's this jelly-like stuff, kind of holds the retina in place, fills the back of the eye. You'll get to see it really well when we do the sheep eye dissection. Okay. The front of the eye, this portion up here, is going to be filled with a watery fluid, and that's called the aqueous humor. The aqueous humor. And that's just kind of the watery portion that fills that front part of the eye. That's the part that builds up, you build up extra pressure with glaucoma and things along those lines. You get extra from there, from that standpoint. All right, and then back to the very top, it says there's 3 layers of the eye. It says include the function. I'm not worried about the function part, but I do want to make sure you know the different portions, right? So fibrous, remember fibrous connective tissue is the real strong stuff. So that's going to include these 2 areas. It's going to include the we'll mark them this way. So our fibrous tunic are going to be these here, the cornea and the sclera. They make the outer covering the eye, give the strength to the eyeball. It kind of makes it kind of rubbery and protective. The vascular tunic is underneath that, and that's going to be your choroid coat. Okay, that's going to be the vascular tunic. Okay, and that includes like all the blood vessels and things like that go through that. That's why it's called the vascular, okay? And then the neural tunic is going to be obviously the retina, right? So that's the layer with the receptors that are going to detect everything, detect all the light, and go from there. So if we were to zoom in on the retina, right? So this is just the back of the eye. Notice where it's kind of showing us here, okay? The back of the eye here. The light coming in this direction, so here's the light. We have 2 types of receptors. We have rods and cones. They're named because of the way they look. So the cones kind of have a pointy shape, and the rods kind of have a more kind of cylindrical shape from that standpoint. And the big difference between them is what they do and how they differ, right? So cones can detect color, okay? But they need pretty good light to do that, okay? So they don't work very well in dim lighting at all. And that's why kind of at night, everything's kind of a black and white and grayish, because these cones don't do very much. And I always just remember the C for, and the C, right? So color cone, okay? And the rods are going to be our black and white vision, okay? And they function with a wide range of lighting, but they function, they're the ones that we rely on when the lighting is low level, okay? So low light are the ones we rely on. All right, and at the back of the retina, there's a spot right here where there are no rods and cones. So you'll notice all the rods and cones here and here on either side, but right where the optic nerve attaches is called the optic disc. It's also called the blind spot. So if you want to jot that down next to it, okay. So the optic disc has no rods and cones, so we actually don't detect any information in there. So we'll do a little activity in class, but it's essentially we fill in the information. No information comes into this spot, so from your other eye, you kind of fill that information in, right? We'll kind of talk about that a little bit more in class, but that's the optic disc or blind spot. There are no rods and cones in the air there. We don't see anything with that portion of the retina. And this is just a cool little picture. This is what your doctors look at when they look in the back of your eye, right? They look through the pupil to the back of your eye, and they can actually see the retina. A couple cool things they can spot about that. Number one, the size of these blood vessels here are indicators of lots of different diseases, right? So with diabetes and other things like that, these can get enlarged or shrunken, right? If there's too much pressure in your eye, they get shrunken so the blood can't get in there. So that's what they're kind of looking at, is these blood vessels in the back of your eye, okay? Here shows that optic disc again, or the blind spot in the middle. And then this is a cool vocab word that I don't think I have any either that you should add in, right? Most people just call it the fovea. That's the area where you have the highest percentage of your cones. So that's your most detailed vision. So when you're trying to, like, if you're looking at something, you're trying to read it, something really small, you instinctively aim that image or whatever you're looking at right on this area, and it gives you the best vision, our sharpest vision right on that fovea. Okay, so the next big topic is accommodation, which you'll see listed here, right? And accommodation's the way we focus, right? It's all about focusing. So if you want to define that off on the side, that's just focusing. We look at things near and far, right? So notice this is what changes, the shape of the lens, okay? So when we are looking at something really close, the lens needs to be really round. It's just optics, it's really physics, but to see something that's close to our face, this lens has to be round to bend it to make sure it fits there on the back of the retina so it's in focus, right? When we're looking at something really far away, we flatten this. We actually, what we do is relax muscles, and it pulls that flat. And allows us to focus, right? Now, what happens as we age, most people have a hard time seeing things up close when they get older, regardless of how your eyes are now. Almost everybody will have a hard time seeing things up close. You'll need reading glasses, because you can imagine if you do this all day long, you take this naturally round lens and you flatten it over the course of your life, it just becomes flatter and flatter and flatter. And if it can't be round, you can't see things up close, right? So that's where a lot of people have to add corrective lenses in there to help with that. So the next thing in your packet is this bit of they call it the pathway of light, and then the pathway of electrical impulses. I'm not going to go through step by step and make sure you have these correct right now, like you guys are trying to do it, and then we'll go over it. But the pathway of light is all about how the light comes in. So think about where it's going to come in. What's it going to hit first? Well, it's going to hit the cornea, then it's going to pass through here, and then pass through here, and then pass through here, and then pass through here, and all the way back to here, right? So that's the direction that you want to look at. So use your notes and try and figure that out. And then the second pathway is the pathway of the electrical impulses. So what we're saying is, now that the light has hit this retina at the back of the eye, how does it get there? And it's going to follow along these pathways. So it's going to go along the optic nerve, and then there's this spot where it crosses over. It makes like an X shape called the chiasm, okay? And then along these kind of optic tracts, which will then take us into the thalamus and the rest of the stuff you guys know. So it's going to go right into the brainstem and up to the thalamus, up those ascending tracts, up to the thalamus, and the thalamus will send it to the occipital lobe and go from there, right? So I'd like to see if you guys can figure out all of those steps on your own. Then we will go over it in class, but I want you guys to give it a shot on your own first. All right, and the last thing that you have on there is nearsighted and farsighted, right? So nearsightedness is also called myopia, and generally what's going on is the eyeball is a little bit too long, right? So you'll notice here that the image is focused here, but it doesn't reach the back of the eye, right? And in hyperopia, the farsightedness, the eyeball is a little bit too short. And you'll see that over here, that it's being focused back here, and it's not focused where it's hitting the retina, so it's out of focus that way. And they just use corrective lenses to help bend the light, right? So the cornea bends the light for you, the lens bends the light, but sometimes we need an extra layer to help bend the light to make sure it's focused. So nearsighted, somebody sees things up close really well. Farsighted, they see things at a distance really well. All right, and that should take you through the stuff that's in the packet. We'll add to it. We're going to watch below. You'll see in your packet there's a couple of videos we're going to watch in class. We'll take questions. We'll do that kind of stuff. But that gives you the basics of how the eye works as a whole. All right, I'll see you in class.